Right, grade 11s, we now just want to hit pause after those first topics and just summarize the rules so far of reduction. We are going to do one more type of reduction, but you'll notice when we get there that it's quite different to these ones. So this is almost kind of, one family of reduction. So let's summarize the rules, and then it's time for quite a lot of practice in order for this to become, for us to become really comfortable with this. So just a quick summary. If we have a Cartesian plane, we can make an angle of theta in the first quadrant. Then we can work out sine theta, cos theta, and tan theta of that angle. So then the question is, what other angles in the Cartesian plane relate to this? Now, you're probably starting to get tired of me saying this, but if you reflect over the y-axis, this angle here will be theta, and therefore the angle that's formed in the Cartesian plane, always remember we move counterclockwise from the x-axis, so the angle that we've actually formed here is 180 degrees minus theta. So that's how we form an angle in the second quadrant. So now we can work out what is sine, cos, and tan of this angle. So if we look at sine of 180 minus theta, we know that in the second quadrant, sine is positive. So this will reduce to the positive version of sine theta. If we look at cos of 180 degrees minus theta, again this is the second quadrant. Only sine is positive in the second quadrant, and so cos is negative, and it reduces to exactly the same ratio as cos theta. It's just the negative cousin. And finally, if we look at tan of 180 degrees minus theta, again, this is the second quadrant, and tan is negative in this quadrant. So this will be the negative cousin of tan theta. So hopefully we start to become really comfortable with this, because basically it's all about what quadrant you're working in, and that dictates the sign. So what is the next cousin that can be made? Well, if you reflect this now over the x-axis, that angle there will be theta, and so the angle that you formed in the Cartesian plane is counterclockwise all the way from the x-axis, and this will be 180 degrees plus theta. So now we can work out what sine and cos and tan and how they relate to the originals. So if we look at sine of this angle, now we're working in quadrant 3. Only tan is positive in quadrant 3, so this reduces to negative sine theta. So this is now the first of the negative sine cousins. If we look at cos, cos is very similar. We're working in the third quadrant. Cos is negative, so this reduces to negative cos theta. And finally tan, tan is the only positive ratio in this quadrant, and so tan of 180 plus theta is actually exactly the same as tan theta. Now our last of the cousins is if I reflect the original over the x-axis, so this is theta, and so the angle formed in the Cartesian plane goes all the way around to the line, and that will be 360 degrees minus theta. Now we're working in quadrant 4. So our first one, which is sine of this angle of 360 minus theta, this will be the negative cousin, simply because we're working in quadrant 4. If we look at cos, this is the quadrant where cos is positive, because this is the fourth quadrant, so this will reduce to cos theta. And finally, you have tan of 360 minus theta, and that will reduce down to negative tan theta, because we're working in quadrant 4. Now hopefully you notice that basically there are two positive cousins and two negative cousins for all of the ratios. We have been talking about this for a while now, and we have been doing the all stations to Cape Town, so it makes sense. So let's just quickly look at sine. Sine is positive in quadrant 1 and 2, and it's negative in 3 and 4. Cos is positive in 1 and 4, and negative in 2 and 3, and finally tan is positive in 1 and 3, and negative in 2 and 4. So you start to become really good at reduction, because all I really care about is what quadrant am I working in, because that tells me the sign of my reduced ratio.